Hello everyone and welcome back. In this video what I'd like to do is I'd like to introduce how we can memorize the sum and difference formulas for factoring sums and or differences of cubes. So notice we've got a cubed plus b cubed, we've got a cubed minus b cubed. This is our sum of cubes. This is our difference of cubes. So sum, plus sign, difference, minus sign, right? So let's get into it. So here's how we remember what the formulas are. So to begin, we want to get a cubed and b cubed out of it, right? Well, what we need then is a and a squared, right? We need to have a sum of 3 with the exponents. Similarly, we need to have b and b squared. So this much makes sense, right? Now what we also need is we need some way of canceling things out. So here's what we do. Without going too much into the reason for it and just focusing on how to memorize it, we keep the same sign here. We keep the opposite sign, or we change the sign there. We make it the opposite sign, and then we multiply the two things together. So we have AB. And then just note, we needed to get plus B cubed, right? So we maintain a positive sign here always. So even in this example, we'll have a plus sign here, so I'll write it now, just for the heck of it. So, and I'll show you why we'll need it. So, and the reason why is because we're going to do A minus B here. We're going to have the same sign, right? So now the reason why we need a plus sign here for B squared is because we need to have minus times plus. We need to get a minus sign, right? So that's why we need a plus sign there. So we just get A squared. And then remember, we also need a AB term. So AB, but then it's always the opposite sign. So since it's minus, we have to do plus. So these are the sum and difference of cubes formulas. If memorizing that is too difficult, that's okay. I'll never expect you to memorize these things, but it is handy to be able to memorize it and to have a nice way of doing it. So hopefully that's helpful for memorizing it, but now let's get into some examples. So example 1, let's just say we have something nice and simple, x cubed plus 1. And let's say I want to factor this sum of cubes. Well, the first thing you want to do always is identify what a is and what b is. So you want to express each of the things as cubes. So you want to express it as a sum of cubes. This writing here makes it more immediately clear that this is a sum of cubes because we have something cubed, x cubed plus 1 cubed. So we've got something cubed plus something cubed. That's a sum of cubes, right? So now we're just going to apply this formula. We have a plus b. That's the same thing as x plus 1 times x squared. And then the opposite sign, we multiply x and 1, we get x. And then we always have a plus sign, and then we have b squared, which is 1 squared, which is just 1, right? So this is x cubed plus 1 fully factored. The quadratic that's right here is not factorable over the real numbers, so we will not worry about that. We will get into, we will maybe get into complex numbers a little bit, but anyway, we just say this is not factorable over the real numbers, so we just say it's not factorable. I think that's fine to say it's just not factorable. All right, so, and I should really be more clear. I'm saying this is not factorable, or we could say this is this whole thing is fully factored. It's factored as much as we can. But yeah, this term right here can't be broken down further. So anyway, let's get into another example, maybe one that's a little bit more complicated. Let's say we have 125x cubed minus y cubed z cubed, let's say. So this is also, this right here is a difference of cubes. So we'll use this formula. So we have to express it first as a difference of cubes. So we write this as a cube, that's 5x cubed, right? And then we express this as a cube. Well, y cubed z cubed would be yz all cubed, because 3 times 1 gives you the 3's you need. So now this is going to be a plus b, that's 5x, or sorry, I misspoke, a minus b, 5x minus yz times a squared, that's 25x squared, plus a times b, that's 5x times yz, 5xyz, plus b squared, which is y squared z squared. So now this is fully factored. So I'm really just applying the formula. If I'm going too fast, what I recommend doing is just slowing down the video or just pausing for yourself to catch up with the calculations if it's going too fast. But just verify you're getting the same thing as me. That's important. So anyhow, let's do, say, 1 or 2 more examples. We've gone for about 6 minutes. So yeah, how about one more nice example? Let's say we've got 1 over 64 x cubed. Let's say we've got y, that's a y cubed minus 1 over 8 z cubed. Let's make it kind of difficult. So first we want to express each of these as perfect cubes. So this is a challenging one. So what do we cube to get y cubed? Well, y, right? Y cubed. And what do we cube to get 64? 4. 4 times 4 times 4 is 64. And what do we cube to get x? Well, x. Or what do we cube to get x cubed? X. So notice if we cube this out, we do get this. Similarly, 1/8 is the same thing as 1/2 cubed. And then just don't forget, we've got this z cubed in the bottom, so that amounts to a z in the bottom. This comes back to section 1.6, where we're taking exponents to fractions. Just remember, it's just repeated multiplication. So now, without going too much into that, let's express, let's apply the difference of cubes formula. So we have, this is the same thing as y over 4x minus 1 over 2z. So this is just a minus b. Maybe I'll write the formula above it. A squared plus ab plus b squared. Maybe that'll help as a visual check instead of being way up here. And then a squared would be y squared over 16x squared. AB would be this times this, so that's just, let's see, we get y in the top, we get 8xz in the bottom. See, now these are some funky looking expressions, right? And then plus b squared, which is 1 over 2z squared, which is 1 over 4z squared. Check that though. Check that 1/2 squared is 1/4, and check that z squared is z squared. Well, I guess that you don't have to check. So anyway, we'll say that this is fully factored. So I think that concludes this video. We started off with a nice and simple one. We did a medium difficulty one, then we built in one that had some fractions and things. So I hope this video was helpful for you with understanding the sum or difference of cubes. Please, if this video was not helpful, I also recommend checking out the sum or difference of cubes memorization video, because it might be better to watch that video first and then get into this video. But anyway, without further ado, I hope you guys have a terrific day, and we'll see you guys in the next video.